had a nice weekend? All right, here we go. So we have been using ratios, which is ratio is just a fraction, and learning to set up proportions. And so that's what we're doing more of today. I think today kind of turns out to be a little bit easier than Friday, actually. But you do still have to read carefully and think about units. So today we're going to be able to use proportions to determine actual dimensions or scale of a drawing, okay? And so we use scales and scale models all the time. Like there's model cars. When designers design things, whether you are a house designer, like you put in the furniture and design the cupboards and stuff like that, we have drawings on paper. And all those drawings on paper have scales. Usually like 1 centimeter is 1 foot, okay? Something like that. Or sometimes it's like 1 inch is 2.5 feet or something like that. So those are scale. And it turns out that the dimensions of an object on the scale drawing or model are proportional to the dimensions of the actual object. And so if things are proportional, then what we can do is we can set up a proportion, which is what we've been doing the last couple of days, where we have a fraction equal to a fraction. So the scale is the ratio of the size of the model to its actual size. And so scale is simply the model unit compared to its actual size. So model over actual. A scale can have same units or different units. Just like I said, sometimes 1 centimeter is the same as 2.5 feet. Okay? And we can use scale to find a missing measure by simply setting up and solving a proportion. So it turns out to be pretty easy. So we're going to solve each word problem using a proportion. And so we're going to start here with number 2. And what we're going to do is we're going to find our scale because it's going to give me some information about the model and the actual size. The blueprint for a house uses the scale 1.5 inches equals 2 feet. That's a really nice little ratio they just gave us, where the actual blueprint drawing, so those are the big blueprint pages, you know what those look like? Have you seen those before? Or, images of them in movies or whatever, right? So they've got those big pages that you got to roll up. Those are blueprints, right? They're pretty big. And so those blueprints use a scale of 1.5 inches is equal to 2 feet. And so the actual house, that single unit represents 2.5 feet. It's pretty big. And then it says if the living room is 18 feet long, find the length on the blueprint. So if the living room is 18 feet, where should that living room information go? Where should that 18 feet go? Yeah, on the bottom. It is 18 feet. Again, ladies and gentlemen, did you put units on there? Yes. The units are super duper helpful. So I encourage you to keep those units on there. It's just going to help keep everything organized. What should we put on top? X, because that's when we're trying to find out the length on the blueprint. That's going to give us an answer in terms of inches, so it matches. And when we set up our proportion, again, we want to just verify that our units match on top and the units match on bottom. Everything will be nice and organized then. So we're going to go ahead and cross multiply, ladies and gentlemen. You're going to want your calculator, it's very handy. 2 times x is 2x. And what's 1.5 times 18? 27. Good. And then we can go ahead and do what? Divide by 2 on both sides. So we get x equals 13.5. And x was on top. That was going to give us inches. So that living room on the blueprint is 13.5 inches long. So that's a good size model there. All right. Do you have questions on that one? Lily, I'm up front. Let's look at me. All right. Number 3. A model car car uses a scale of 2¼ inches equals 3 feet. So that is my scale where we've got the model would be 2¼ 2¼ I don't really like using 2¼ Can I convert that to a decimal?
Yeah.
What is that decimal? 2.25. Very good. 2.25. A quarter. 1/4. How many cents is a quarter? 25 cents. Okay, so 2.25 inches equals 3 feet. So that's my scale. 2.25 inches is the same as 3 feet on this little model car that we've got. And then it says, if the model is 14 inches long, what is the actual length? Where should that 14 inches go? Top. Because that's information about the model. And we want everything about the model on top and everything actual on the bottom. The actual length we're trying to figure out, that's going to be the X on the bottom. And that's X feet. So again, did you put units on there? Mm-hmm. The units are helpful. Put them on there. Keep them on. I'm going to just multiply my X first always because this makes life easier. X times 2.25 would be 2.25X. And then we have 3 times 14, 42. Okay. How do we get X by itself? Divide by 2.25. So we get X equals, let's see, 42 divided by 2.25. I get 18.6 repeating. Yeah, that's really 18.6 repeating. So that's 18.6 repeating feet. What if, so this started with a mixed number. Can we maybe turn it into a mixed number? How do we figure that out? Yeah. Okay. Can we just math frac it? So if we math frac it, we get 56/3. That's not a mixed number though. Is it 1/3? That decimal, is it 1/3? So here's what I'm going to do. 2/3. It's 2/3. Yes, it is. That's a good one to know. 0.66666 is just 2/3. If you remember when at the beginning of the year, any repeating decimal is just something over 9. So this is actually 6/9, if you remember that. But that's kind of, 6/9 reduces to 2/3, as Odin said. This is a good one to know. It's a very common fraction. But I do want to show you how to do this on the calculator. So I'm going to go back here. So there's our 18.66666. Now, if I want to figure out whatever the decimal portion is as a fraction, what I can do is actually just subtract the whole. So I know that there's 18. I just want to subtract 18. That's just going to leave me with the decimal. And now, if I just want that decimal as a fraction, so just that, I can now do the math frac. And so you can see that it gives me 18 2/3 feet. Okay, so you can subtract the whole, and that'll just leave you with that fractional portion of the mixed number. So it's a good way to do that. All right, number 4. The scale on a map reads 2 inches equals 125 miles. So we have the model over the actual. And let's see, it says the model is 2 inches. And the actual is 125 miles. And we want to know if 2 cities are 4 3/4 inches apart on the map, what is their actual distance? So where should we put the 4 3/4? On top, because that's the on the map. So that's the model information. I don't like 4 3/4 as a decimal. What is that? 75. 4.75. Remember 3/4. How much money is 3/4? 75 cents. Okay. So 4.75 inches. And the actual distance, that's my X. and we want to figure out how many miles that is. So there's our setup, there's our proportion, and we can cross multiply. Again, I'm always just going to go with the x first, wherever that is. X times 2 gives me 2x, and then 125 times 4.75, we get 593.75. And then how do we get x by itself? Divide by 2. So we get x equals 296.875 miles. And again, they gave us a mixed number. So traditionally in math, if they gave us a mixed number, that's what we want to end with. Also mixed number, whatever we start with, we should end with. So again, how do we figure out what that decimal is as a fraction? Subtract the whole, so subtract 296. That leaves me just with the decimal, and now I can math bracket 7/8. So we get 296 and 7/8 of a mile. 296 and 7/8. Also, 0.875, just for giggles here, so you know. What is the proper name of that decimal? 875,000, right? Yeah, 875,000. So if you ever didn't have a calculator, the proper name tells us its fraction. 875 over 1,000, 875,000, okay? And then all you have to do is reduce that, which of course we can track, but you would divide by 5 until you couldn't divide anymore, okay? But there it is. So it's another way to do it. Okay, number 6. Number 6, the scale model of a new building was created for approval by the city. The scale of the model is 3 inches equals 20 feet. 3 inches is 20 feet. And that is the model on top and the actual building on the bottom. It's important that you keep that straight. We got the model on top and the actual size on the bottom. It says if the model is 5 feet tall, the model is 5 feet tall. How tall is the actual building? So where do we put the 5 feet is my question. At the top. Okay, here's where we have to be smarter than our units, okay? So it says the model is 5 feet tall. This is information about the model. It tells us it's 5 feet, but can I do this? Can I have 3 inches is equal to 5 feet on top? No. Oh, okay. So 5 times 12, yes. We have to convert that into the same units. So that would be 60 inches. But it's important that you know where to place it. It's information about the model, so it has to go on top. But we also have to make our units match. Okay, so that's really, really important. We want to know how tall is the actual building, so that means the X feet is going to go on the bottom. That's the actual thing we're trying to figure out there. Now I can cross multiply. Let's see, X times 3 is 3X. And 20 times 60 is 1,200. And then we can divide by 3. And we get 12 divided by 3 is 4 with 2 zeros, 400 feet. So the model of this building, so you got to imagine an architecture student, right? He's got to build his scale models for his building that he's designing. His model is 5 feet tall. The actual building, 400 feet tall. Okay, this is a big building, very tall. Okay, 40 stories. This is a skyscraper. Okay, big. All right. Turn the page. We're going to look at number 10. Number 10. The crack in the Liberty Bell is approximately 24.5 inches long. Is that a model information or actual information? Actual information. If a model of the Liberty Bell uses a scale of 3 inches equals 5 feet. So again, we have our model over our actual. The model is 3 inches in size. The actual is 5 feet in size. And they just gave us information about the actual Liberty Bell. The crack on the Liberty Bell is 24.5 inches long. So we want to know what is the length of the crack on the model. So where does this 24.5 inches go? The bottom, 24.5 inches, goes on the bottom because it's the actual length. So we got to go with the actual. And we're trying to find the length of the crack on the model, so we want to figure out the length on the model. But what's the problem with our setup here? They're not the same units, right? So what we've got to do some converting here because we got to make these units match. So do you want to convert inches or do you want to convert feet? Yeah, we usually convert the bigger unit. It's easier. Yeah, so again, that's 5 times 12, which is 60 inches. So we're going to cross that out and turn that into 60 inches. All right, so really important you get things placed in the proper location. Is it information about the model or is it information about the actual thing? And then make sure your units match. We got inches on top and we got inches on bottom, so we can go ahead and solve it this way. All right, so I've got 60 times x, that's 60x. And I have 24.5 times 3. 73.5, thank you. And then we're going to go ahead and divide by 60 on both sides. 1.208333. Ooh, what?
I got 1.225.
Yeah, 1.225 inches. All right, questions on that? We don't. We're not done yet. Hold on.
Oh.
All right. So the one more thing that we might want to know how to do is actually find the scale. If we're given a drawing length and an actual length, we want to find the scale that that drawing is being used in. And so we can do this pretty easily. We're going to write the ratio of the model to the actual. So we have whatever the model size is over the actual, which is sort of what we've been doing this whole time. The model over the actual. And then to actually find the scale, we want to simplify the ratio so that the numerator is 1. To do that, we simply divide by whatever the model is so that we get a numerator of 1, okay? So we're going to divide the fraction top and bottom by whatever that model is. Let's see how this works. So my drawing, which is my model, the drawing was 9 inches and the actual was 45 feet. So we're talking about like a mural on the side of a building, all right? That mural on the side of the building is like 45 feet long, but the drawing that it came from was only about 9 inches, okay? So we want to figure out how that scale is. And so I want the numerator to be 1. What should I divide by? 9, sure. So we're going to divide top and bottom by 9. And that's going to give me 9 divided by 9 is 1 inch over, what's 45 divided by 9? 5 feet. And so our scale is 1 inch is equal to 5 feet. So 1 inch on our little drawing is equal to 5 feet on the wall, which is kind of interesting to think about. So again, we want to set up a little ratio of the model to the actual. Our model length is 6 2/5. How do we convert that? So we can just do the fraction. We can say 2 over 5. That gives me 0.4. So just that fractional part is 0.4. What is the decimal then? 6.4. Yes, 6.4. We could also multiply and add, so you could get 30 plus 2 is 32 over 5, and 32 over 5 is 6.4. Okay, so either way you do that, you can just say, what's the fraction first, and then add the whole. All right. So the model is 6.4 meters, and the actual length is 120 kilometers. So when we're finding scale, we want our numerator to be 1. So what should I divide by? Yeah, divide by 6.4 on top and bottom. So we get 1 meter on top, because 6.4 divided by 6.4 is 1. And then 120 divided by 6.4 is 18.75 kilometers. So our scale is 1 meter equals 18.75 kilometers. So pretty traditional to give scale where something is 1 inch or 1 centimeter or 1 yard, something like that. And then the other thing has a number. Do you guys have questions for me? Okay, today we are doing a math lab sort of stations.